Namaste everyone. Welcome you all to Sadvidya Academy Physics classes by Ganesh Shaban. Today's topic is Class 11 Physics, Chapter number 1, Units and Measurements, Part 6, Dimensions of Physical Quantities. In this topic, we shall discuss about dimensions of a physical quantity. What are dimensions? So, we shall discuss about the definition of dimension. So dimensions of any physical quantity are the powers to which the basic physical quantities must be raised. So that means basic physical quantities are nothing but mass, length and time. That must be raised to get that physical quantity. We write the dimensional formula of any physical quantity inside square brackets. So, what is a physical quantity? What is a physical quantity actually? There are two types of physical quantities. One is the fundamental physical quantities and derived physical quantities. Right? We have discussed already. So, one is fundamental and one more is derived. So, here dimensions of any physical quantity. Any physical quantity, or that means in specific this is derived physical quantity, is derived out of the fundamental physical quantities. So which are the fundamental physical quantities? Mass, length and time. We have already discussed that mass, length and time are the fundamental physical quantities. They are not depending on any other physical quantities, and using mass, length and time we can derive all the other physical quantities we have discussed. That means any physical quantity can be written in terms of mass, length and time by raising the power of each physical quantity to certain values. So that powers to which we raise the physical quantities to get the required physical quantity, that we call it as the dimensions. Say for example, area. What is the formula for area? Area is length square. Here it is actually length. Square of the length is nothing but area. Right? That means area is a derived physical quantity which can be derived by raising the power of length to 2. Are you getting the concept? So say, therefore, what we can say says area has two dimensions in length. That is called as two dimension 2 in length. And how many times you have to raise the power of mass in order to get area? No, it is independent of the mass and time. Which one? Area is independent of mass and time. That is why we need not raise the power of mass and time to any number to get the area. That is why in order to get the area, that is a physical quantity, we have to raise the power of length to 2. So that 2 number, that is called as the dimension of area. So we can say that area has two dimensions in length, zero dimensions in mass and zero dimensions in time. Then how to write the dimensional formula? So dimensional formula of area is written as m to the power 0, L to the power 2 and T to the power 0. That means no need to raise the power of mass and time. That is why I have written to the power 0, and L square. We have to raise the power of length to 2 to obtain the area. That is the meaning of area. That is the meaning of dimensions of a physical quantity. Let us discuss that by one more example. So how to write the dimensional equation of area? So I can write, always we write the dimensional equation by putting them inside the square brackets. So square bracket I have kept. So for area, which is equal to m to the power 0, L to the power 2 and T to the power 0. We shall discuss one more, that is volume. So by mistake I have written volume twice. So okay, no problem. So you can neglect this. Okay, volume is equal to how many times I have to multiply length In order to get volume, I have to take length into breadth into height. Even if it is breadth or height, it is nothing but the length only. So length to the power 3 or length cube. So what will be the dimensions of volume then? Volume will be, it has 3 dimensions in, therefore volume has 3 dimensions in length, and no need to increase the power of mass and time. It is independent of mass and time. So 0 dimensions in mass and time. That is the second example about volume. Let us discuss one more example, that is dimensional formula of volume. Then we shall discuss the dimensional formula of volume. How to write it is m to the power 0, L cube and t to the power 0. This is how to write the dimensional formula of volume. So no need to raise the power of m and t. That is why we write 0 in m as well as t. So but L we have to raise to the power 3 in order to get volume. That is why dimensional formula of volume is m to the power 0, L cube and t to the power 0. Next dimensional equation how to write inside the square bracket. That inside the square bracket v is equal to inside the square bracket m to the power 0, L cube, t to the power 0. That's the dimensional formula of volume. We shall discuss some more examples in the next slide. Few more details regarding the dimensions of a physical quantity. Next we shall discuss about the dimensions of density. First, what is the formula for density? That is, formula for density rho is equal to mass by volume. So in order to how to write it as, therefore I can say, but how to write volume? Mass divided by volume. Volume means length to the power cube, or if I write it in terms of in the numerator itself, mass into length to the power minus 3. When it comes to the numerator, it becomes to the power minus 3. It was in the denominator L cube, that is volume. So mass by volume. When it comes to the numerator, it becomes m into m to the power 1 into L to the power minus 3. That is the formula for volume. Then by looking at the dimensions, how can we say that what is the dimensions of density? Therefore density has one dimension in mass. So m to the power 1, that is one dimension in mass, and minus 3 dimensions in length, and 0 dimension density is independent of time. So I can write m to the power 1, L to the power minus 3. That means by using the formula mass by volume equal to density, but volume is nothing but L cube. When it becomes L is nothing but the length. So m to the power 1 into L to the power minus 3 becomes a formula, that or the dimensional formula of density, or dimensional formula. How to write then? M to the power 1, L to the power minus 3 and t to the power 0. No, it is independent of time, that is t to the power 0 inside the square brackets. Similarly, how to write the dimensional formula or the dimensional equation, or density rho is equal to m to the power 1, L to the power minus 3 and t to the power 0. So next we shall discuss one more example. What is the next example? That is about velocity. What is the formula for velocity? It is distance divided by time. Distance is nothing but the length. Length divided by the time. So, but when it is, length is in the numerator only. So L to the power 1 and t time, when it comes to the numerator, it was in the denominator. When it comes to the numerator, it becomes minus 1, L to the power minus 1 you will get, and it is independent of the mass. So mass to the power 0 you can write, no need of writing that. And while writing the dimensional formula, what do you write? It has one dimension, therefore velocity has one dimension in length, that is L to the power 1, and minus 1 dimension in time, and 0 dimension in mass, that is velocity is independent of the mass. So 0 dimension in mass. And how to write the dimensional formula then? That is easier. Already we have written, that is m to the power 0 because it is independent of mass. We are not raising the power of mass to any number to get velocity, and L to the power 1 into t to the power minus 1, m0 L1 t minus 1, or the formula dimensional equation is V equal to, inside the square bracket, m0 L1 and t to the power minus 1. Let us discuss one more example so that when I give you many examples, the concept will be crystal clear to you. Next concept is force. What is the formula for force? Force is equal to m into a, where m is the mass and a is the acceleration. A is nothing but the acceleration. So what is the formula for acceleration? It is nothing but velocity divided by time. So mass already it is there, mass into acceleration can be written as velocity by time. But what is velocity by time? Velocity by time is nothing but distance by time. Already there is one more time. So I can write how does this particular formula has come, that is mass into velocity. Velocity is nothing but distance by time, and already distance by time is velocity. Velocity by time is there, and into 1 by time again. So I can write mass into distance L, that is length, divided by time square. But when it comes to the numerator, I can write m mass to the power 1, L to the length to the power 1, and t to the power, it is in the denominator first. When it comes to the numerator, it becomes minus 2. So what we can call, well, force has one dimension in mass, one dimension in length, and minus 2 dimensions in time. It is dependent on mass, length and time, all the three quantities. Previous all these examples, it was not dependent on all the three fundamental physical quantities, but here the force is dependent on mass, length as well as time. It has one dimension in mass, one dimension in length, and minus 2 dimensions in time. Next, how to write the dimensional formula then? M to the power 1, L to the power 1, and T to the power minus 2 is the dimensional formula of force. Now how to write the dimensional equation? That is force F is equal to m to the power 1, L to the power 1, and T to the power minus 2 inside the square brackets. So that is the dimensional equation of force. And one more, momentum. What is the formula for momentum? We shall write that momentum formula for momentum first. That is mass into velocity is the formula for momentum. We will study that in the future classes. That is momentum. Momentum is a physical quantity which is dependent on mass and velocity. So mass, m is nothing but the mass, into velocity. Velocity can be written as distance by time. So I can write mass is m only, distance is nothing but length, length to the length, and time is in the denominator. When it comes to the numerator, it becomes minus 1. So m to the power 1, L to the power 1, and T to the power minus 1. So how to tell the dimensional what are the dimensions of momentum? That is one dimension in mass. Momentum has one dimension in mass, one dimension in length, and minus 1 dimension in time. These are the dimensions of momentum. And next, two dimensional formula, how to write? M to the power 1, L to the power 1, and T to the power minus 1 inside the square brackets. And how to write the dimensional equation? Equation in terms of equal sign, that is momentum P, dimensions of momentum is equal to inside the square bracket m to the power 1, L to the power 1, and T to the power minus 1. How to read this? Momentum has one dimension in mass, one dimension in length, and minus 1 dimension in time. These are all some of the examples. So for more details, for many examples, you can go through your NCERT textbook, in which they have given many dimensional formulas of many physical quantities, and while we are discussing about the theory of all the other chapters at that time, we also discuss about the dimensional formulas. So this is all about the dimensional equation and dimensions and dimensional formula of any physical quantity. Thank you.